What's up, guys? Just gonna do a little recording here for you to go over your checkpoint quiz that you took yesterday. We'll walk through it and see what's up. Okay, so for the first learning target, basically what we remember, kind of the deal is we say likes, dissolve, likes, right? So polar and then non-polar. That's kind of the key terms. All right, so in this case here, what we're looking at, we got to know what polar is, and polar is basically anything that's not just carbon and hydrogen. So anything that's carbon and hydrogen is non-polar. Everything else we're going to classify as polar. All right, so water is the definitely polar. All right, so which of the following will dissolve in water? So water is polar, so we got to find all the polar ones. Okay, NaCl, it's an ionic compound, that's polar. It's carbon and hydrogen, that's just non-polar. Barium and hydroxide, that is polar because it's ionic. Okay, and then this is non-polar because it's just carbon and hydrogen. So that we're going to go with A and C. All right, as the answers. So with ethanol and water, so water is polar. All right, and the next thing is ethanol. Yeah, there's carbon and hydrogen, but we say since that oxygen is there, it makes it polar. So what we're going to say then is it's a homogeneous solution, B. All right. The next one, okay, octane, just carbon and hydrogen, that is non-polar. And ethane, that's just carbon and hydrogen, that's non-polar. So likes dissolve likes. Polar mixes polar, non-polar mixes non-polar, that is B. Okay. So water, oil, and gasoline are mixed together, right, and left in a beaker to settle. How many layers are we going to think about? So you got this beaker here. You mix it together, right? And so basically the polars are going to mix with polar, okay? And the non-polars are going to mix with non-polars, right? So water is polar, okay? Oil is just carbon and hydrogen, right? And this is good to know tomorrow because you're going to have the exact same question on your test. Oil and water don't mix if you use your knowledge is non-polar. And gasoline is also non-polar. And I'm kind of relying on your inference of, hey, oil and water never really mix. If you look at an oil spill in the ocean, or gasoline and water never mix. So you're using your inference there. So how many beakers? So we'll have, this is non, so the nons will mix. And then the polar, so there will be two. D. You'll have the exact same question like that tomorrow. Something similar to that. Just know that oil and gasoline are non-polar. All right, which of the following compounds will dissolve in oil? So oil is non-polar. All right, so water is polar. Okay, ionic compound, polar. C4H10, non-polar because it's just carbon and hydrogen. And this is polar because it's got a metal. All right, so then what's going to be? It's going to be C there. All right, so that's the first learning target there. Moving on to the next one, we got a little bit of math here. All right, so the first one, we're going to talk about molarity. And remember, it's got to be in moles and it's got to be in liters. All right. So if I look at this, calculate the molarity of a 6.0 mole solution in 2.5 liters of water. All right. So then with your math, you do 6 point, and that becomes 2.4 molar. We don't have to do any conversions because we're in moles and we're in liters. All right. Calculate the molarity of a solution if you have 19.8 grams. All right, in a 3.65 liter solution. So if I want to figure out big M, I got to find moles. I can't just plug in 19.8, and I know it's 3.65 liters. All right, so how I figure out moles is, all right, I got 19.8 grams of LiOH. How many moles is that? Well, how many moles is that is going to be? I got to do a molar mass conversion. And I look up Li and I look up ONH on the periodic table, and I find out that 1 mole of it is equal to 23.95 grams. That gives me 0.82 moles. Okay, so now I can plug that in there. So the molarity then is equal to 0.82 divided by 3.65 liters. All right, and that becomes B, 0.22. So we got BB. Okay, and that's kind of the gist of that. You got to figure out in this problem, what am I given? What do I have to solve for to be able to do that? All right, so now calculate the number of moles in a 5.0 liter solution at 0.075 big M. So we got 0.075 big M. We want to figure out the number of moles, and it's in a 5-liter solution. So I just got to solve for X there, basically. So 0.075, and I would multiply times 5 to get it over here, right, to cancel it out. And what that gives me is 0.375. All right. Okay, so we got a little legwork here. How many grams is what it asks for of sodium nitrate, NaNO3. So here's what we got to do. We're given a 1.25 big M. I know it's 0.725 liters. I just divided that by 1,000 to get into liters. Okay. I got to solve for moles first to figure out grams. All right. When I solve for moles, I get 0.21 moles from here. So I just multiply by 0.725 times 0.725. So then I cross that out. Okay, so I got 0.21 moles of NaNO3. Now what I need to do then is I need to convert it to grams. All right, and when I convert it to grams, 1 mole is going to go on the bottom because that's what I'm given here. And it's the molar mass. If I add up Na, N, and 3 O's, it's 84.99 grams. All right, then my final answer becomes 77.34 grams. So if you want to make a 1.25 molar solution that's 0.725 liters, you will need 77.34 grams of that. All right, so manipulating the molarity equation, that is kind of the deal for learning target 2. All right, learning target 3 is all about solution double replacements. All right, if you remember the pattern, okay, we're going to switch A and C. Okay, we're going to switch the positives, and you're going to get B, CB. Okay, there you go. So we're going to switch the positives, and then that's what it'll be. Okay, remember, 2. The other thing is one of these has to be a solid, and one of them has to be an aqueous. And then we have a process to do that using our solubility. Okay. So what does insoluble mean? Well, insoluble means that it's a solid. Okay. What does soluble mean? It means that it's an aqueous solution. B. Okay. Using your solubility table, which one is soluble or insoluble? Let me pull up a periodic table here quick. Sorry, should have had one up. Too bad. Two. Okay. We're going practice. Pull up your periodic table. And we go to the chart. Okay, so if I go to the chart here, what I'm going to find out is which one is insoluble, LiOH. Okay, let's just do this. This will be easier. So if I have LiOH, right? LiOH, okay, hydroxide OH. It's insoluble except with group 1 metals. Remember what group 1 metals are, is they are the elements here. So Li is a group 1 metal, so that would make it insoluble except when it's with Li. So that one is AQ. Okay. Acetate, C2H3O2. That's soluble, so that's AQ. SrSO4. So it's soluble except when it's with calcium, barium, strontium, AgH. Okay, boom, we hit an exception. That one is solid. So C definitely is it. Nitrate, NO3 is soluble. That's AQ. So the answer is C there. Which one is soluble? All right, OH. OH is insoluble except with group 1, barium. So that one's okay, barium. That one makes it AQ. Let's look at I. Halides, okay? It is soluble except when it's with AgHgPb. Well, that one is soluble, AQ, okay, because it's an exception. CaCO3, okay? Insoluble except with group 1. Well, calcium is a group 2 metal, so that would make it solid. Okay, so far we got A, B, and then let's look at D. D is Br. Soluble except with Ag. Okay, so that one is solid. That one is a solid as well. So the answer then is A, B. I gotta fix that on the answer key. And that's that. Okay, so the next one. Now we're gonna figure out if this is gonna be, does this chemical reaction happen? Right? So what has to happen is one of them has to be a solid and one of them has to be aqueous. If they're both aqueous, then there's no reaction. Okay, so here we go. If I'm looking at this, let's look at OH. Well, OH is insoluble except with group 1 barium net. Okay, so that one is insoluble. There's no exception there. Solid. NO3, that one is aqueous. So if we say yes, this reaction will happen. All right. Predict the following. So now we actually got to switch charge balance. I got one of them written out for you. So every time we always just write the charge. +1, -1, +2, -1, okay, and then +1, -1. Switch the positives, NaCl, that one already switched, and then we go Cu, and then OH. And we write the charge by each, so that's +2, -1. I need 2 of these, so it's CuOH2, okay? Predict the following of the double replacement reaction, okay, and then we say, well, let's look. Is it a solid or is it insoluble? Right? So OH is insoluble, so that would make that a solid. So the answer would be B. Important thing there is when you switch the charges, you got to have parentheses around the OH. Okay, last one. Ready? Predict the products. So let's write the charge. So I got +1, -2, +2, -1. Okay, so I'm going to switch the positive CaSO4 plus NaI. And when I have NaI, okay, I write the charges by each. So Ca is going to be +2, SO4 is going to be -2, because I just bring the charge from over here. Na is +1, I is -1. All right, now let's make sure our charges cancel out. +2, -2, +1, -1. Now let's balance it. Okay, and I go Ca is 1 over here, 1 here. SO4, 1 there, 1 there. Na is 2 over there, so I need 2 here. That also helped me with the I's as well. Now let's do the solubility chart. Okay, and when I look at the solubility chart, SO4. Soluble, except it's insoluble with CaBa, so Ca fits the rule for the exception. That one is a solid, okay? And then NaI is aqueous. All right, so just ran through it all for you, and the answer then is D. Bam. Okay. Ran through it all there for you. Should be good. Click back if you need to. But awesome, guys. Hopefully you're ready for tomorrow.